Now let's take a closer look at this very important part, the wall roof junction, and see what kind of components and terms that we have associated with the wall roof junction. We've seen that we have the stud right here, and we have a top plate, but then we have another top plate that binds the different wall sections together, and it's often called the double top plate. We can say that we have double top plates here, but sometimes this top plate is referred to as the double top plate. On the inside of the wall, we have drywall. And underneath the drywall, we may, but not necessarily, have a vapor barrier. And we have a vapor barrier in climates that are very cold climates, because in cold climates, there's a very large moisture difference between the indoor air and the outdoor air during the winter time. And the moisture from the interior wants to go through the wall this way toward the exterior. So we want to stop it right there. And that's just in a very cold climate. In most climates, we don't want a vapor barrier. So that's the interior. Then, again, we have the ceiling joist or bottom chord of the truss. Here is the top chord of the truss, or the rafter. Now let's start from the top up here. We have shingles and a weather-resistant barrier, or something else called underlayment. Now, you know that a felt is usually installed underneath the shingles, asphalt felt. And the asphalt felt is either called the underlayment or the weather-resistant barrier or the water-resistant barrier. And shingles are not an absolute water barrier. We refer to them as more of they're the roof cladding. The cladding of the wall is the siding. And cladding is an imperfect water barrier. So we assume that some water is going to get through these shingles, and we're going to need another barrier right here, which is the weather-resistant barrier or the water-resistant barrier, or the roof underlayment. And on the edge here, we generally have some kind of a drip edge that allows the water flowing off of the roof to drip off of the edge. And what we don't want the water to do is to follow this edge and to come down here along the fascia board. Now this is the fascia board. The fascia board is the decorative trim board that goes along the edge of the roof. And the subfascia board is the structural board that is attached to the end of the rafters or the end of the top chord of the trusses. So again, this is a section. We've cut through this section. We're looking at an enlargement of this area right here. And so we have the siding here, which is the cladding for the wall. And behind the siding, again, we have a water-resistant barrier or a weather-resistant barrier. Something like asphalt-impregnated felt, or a newer product called house wrap that is made from a product called Tyvek, which is a kind of a woven polyethylene that allows water vapor to go through it this way, but will not let rainwater that gets through the siding go through this way. It forms what we call a drainage plane. And a drainage plane is a small space. It may be anywhere between, you know, 1/16 of an inch and say 3/4 of an inch, depending on the climate. And it's the space between the sheathing. Now, this material right here attached to the wall, be it plywood or oriented strand board, it's called the wall sheathing. And this material here is called the roof sheathing. It's what sheathes the roof. But this space here between the sheathing and the siding, created by the weather-resistant barrier, created by the slight irregularities in the siding, is enough to stop the water. The water gets through the siding somehow, and it gets to this weather-resistant barrier, and then it's able to drain out, or the weather-resistant barrier holds the water until it can dry out. And it might dry out toward the inside, and it might dry out toward the outside.